Okay, guys, turn to page 33 in your Unit 1 packet for the last lesson on inequalities. Welcome, welcome, welcome. Okay, so we're going to model inequalities in some word problems. And here are some steps for you to follow in doing that. Now, I have already prepped our notes today by reading the 4 problems, writing what the X or the unknown for each word problem would be, and then writing the inequality equation that would represent that word problem, and I have not solved them. Okay, so let's talk about number 1. You're ordering a book off Amazon for $19.76. Amazon offers free shipping on orders of $25 or more. You do not have Amazon Prime. Write and solve an inequality that represents how much more you must spend to get free shipping. So X represents the amount of money more you would need to spend in order to get that free shipping. So writing that as an inequality would be 19.76 plus X, we don't know how much that is, would be greater than or equal to 25 because $25 or more would represent the greater than or equal to sign. And you would solve for X. Number 2, the maximum speed for a school bus is 55 miles an hour. Write and solve an inequality that represents the number of hours it takes to travel 165 miles in a school bus. So because it said maximum speed, that means less than or equal to. X represents the number of hours it could take to drive that 165 miles. So the inequality would be the maximum, the longest it would take, or excuse me, the quickest it would take is if you went 55 the entire time, which we know is not realistic because you have to pump the brakes. You're going to have to stop at Whataburger to get the kids something to eat on the way, wherever you're going. So 55X is less than or equal to 165 miles. Number 3, you're flying back home after your summer vacation. Originally, your bag weighs 38 pounds. The airline you are flying on has a weight limit of 50 pounds for each checked bag. Write and solve an inequality that represents how much weight you can add to your bag. So X represents the pounds you can add to your suitcase. So it's currently 38 pounds, 38 plus X, how much more you can add before it hits 50, less than or equal to 50. So the weight limit of 50 pounds would be less than or equal to. After saving up $75, you plan on shopping at H&M to buy a jacket and 2 shirts. The jacket cost $37.88. Write and solve an inequality to determine how much you spend on each shirt, including tax. So X represent the amount of money you could spend on each shirt. You're going to buy 2 shirts. You're going to buy a $37.88 pair of jeans. So $37.88 plus 2 shirts, 2X, has to be less than or equal to $75 because you only have $75 to spend, which is less than or equal to. Okay, so some key phrases. This is page 34 of your packet. We have 10 expressions, or 10 sentences. And each of these sentences has a phrase that tells you if you're going to use a less than sign or a greater than sign, a less than or equal to sign, or a greater than or equal to sign. here we go. A number x is greater than 3. So is greater than goes under the greater than sign. Is greater than. Okay, let's move on. A number x is greater than or equal to 0. So it could also use the phrase greater than or equal to 0. I guess we don't need the 0. Just greater than or equal to. You would use a greater than or equal to symbol. Okay, the next one says a number x is less than -1. So that would be a less than. Is less than would make a less than sign. 7 is more than -1. So is more than is another way of saying greater than. All right. Our next question says a number x is less than or equal to 5. All right, here we go. Less than or equal to would be an example of a less than or equal to sign. Okay, a car is worth no more than $25,000. So this is tricky. So no more than means it can be $25,000, but it can't be over that. So that means it would have to be less than that or equal to that. So no more than means less than or equal to. An ACL general admission 3-day pass is at most $273.65. At most means it can't be more than $273. It could be equal to $273.65, but nothing more than that. So that would mean it could be less or equal. So at most would be less than or equal to. I need at least a 70 to pass the Algebra 1 class. So at least a 70 says it's a minimum of 70. Anything higher also works. So this is an example of greater than or equal to is at least. A drink in the Austin High vending machine is no less than $1. So no less than $1 means it ain't cheaper than $1. It's more than $1 or it's equal to $1. So no less than would also mean greater than or equal to. So those are the two tricky ones. No more than really means less than or equal to, and no less really means greater than or equal to. And last of all, 5 is fewer than 10. So is fewer than would be less. Okay, so let's check out our statements now that we have them color-coded and all. For the less than, it's less than and fewer than. For greater than, it's is greater than or is more than. For less than or equal to, we have 3. Less than or equal to, no more than, and at most. Greater than or equal to, you would have greater than or equal to, at least, and no less than. Cool beans. Okay, this leads us to a new page that was not in your packet. And this is called the new page, compound inequalities. I love teaching compound inequalities. So let's talk about it. Compound inequalities, there's two different kinds, hook 'em horns. One, we have an and statement, and two is a or statement. So let's read about how we can apply and statements and or statements to the real world. Imagine you are in a 10-story hotel. You can get on the elevator at ground level and ride all the way up to the top floor at level 10. The path of the elevator can be graphed on a number line. This is an example of an and statement. You can start out at level 0 and ride the elevator all the way to level 10. So our and statement talks about a range of numbers between the smallest number it could be and the greatest number it can be. Okay, in this hotel, when people walk into it, they're on floor 0, ground level. They can hop on the elevator and ride between 0 all the way up to 10, the 10th floor. So in words, we would say your solutions are all real numbers greater than or equal to 0 and less than or equal to 10. That's the path of the elevator. So how do we write it as an inequality? Would be E for elevator's path is greater than or equal to 0 or less than or equal to 10. How to graph the solutions would be a solid dot on 0, because you could get on the elevator at ground 0, a solid dot on ground 10, on level 10, story 10, because the elevator can travel all the way up to the 10th floor, and a solid segment connecting these two because the elevator path can go anywhere in between 0 and 10. Now, in real life, people are not going to get off of the elevator unless it's at floor 1, floor 2, floor 3, and so on. Some other examples of an and statement would be temperature. The low today is going to be 73, and the high today is 101. So you could graph the temperatures starting at 73 all the way to 101, and throughout the day, the temperature will rise to the hottest part of the day, fall back to the coolest part. Distance, height. In order to ride a ride at an amusement park, you need to be taller than 42 inches, but you can't be taller than 167 inches. A speed of a car. It's unsafe to drive a car on the highway, below or above certain speeds. So that example actually is an or statement, but speed of a car would be between 0 and 55 on the highway. Okay, age restrictions. What I mean by that is you have to be a certain age to do certain things in the real world. So we could graph that. And seating at a restaurant, a table at a restaurant can only hold so many people. So a table that has 4 chairs could hold 0, 1, 2, 3, or 4 people. And we could graph that on a number line. So here are some cool signs I found on the web that would represent a and inequality. How many people can go swimming in a pool? The number of people at a banquet. For the fire code, you have to have between this number and this number, or you're out of fire code. You could get in trouble and get fined. Okay, let's move on to what an or statement is. Here's our application in the real world. A golf cart has an efficiency of gas depending on the speed. Going less than 5 miles an hour or more than 15 miles an hour burns more gas. Bet you didn't know that. The efficiency of the gas can be graphed on a number line. This is an example of an or statement. So in words, all real numbers less than 5 or greater than 15 would have poor gas efficiency. So we could represent that using a symbol as G is less than 5 or G is greater than 15. Graphing it on a number line, we would have an open dot, open circle on 5, shading it less to the left. And also an open circle on 15 means it can't be 15, but it can be more than that, shading to the right. So another way to say it is ors go opposite and ands come together. All right, and should be together and or should be going opposite directions. And as I was saying earlier, unsafe speeds on a highway, going 0 to 40 on the highway is unsafe. But then also going over the speed limit would be unsafe. So if we looked at that on a number line, you would have your unsafe speeds that are lower numbers on the left and your unsafe speeds that are above the speed limit on your right. That's an or statement. Sometimes time can be an or statement, like the one at the parking here. No parking before 6 a.m. or after 9 a.m. That's when you are not allowed to park. So you would have before 6 a.m. graphed on the left or after 9 graphed on the right. Okay, and let's just take a look at page 35 on your packet. We can do a couple together, and I don't know how to make this paper turn on its side. Let's see what this does. Oh. I don't know what I'm doing. Oops. Okay, don't know how to do that, so we're just going to read sideways. Okay, so I want you to read the statement with me. Decide if this is an and coming together, or is it an or going opposite? And then let's graph it and then write it. Okay, here we go. I am thinking of a number that's greater than -8 and less than or equal to 4. So let me grab my pen. I'm thinking that this is greater than -8, and then it says the word and. So it gives us two statements, but they connect it with an and word. I'm going to say that this is and. All right. And it says we need a -8. That's an 8, by the way, people. And less than or equal to 4. So it said less than or equal to 4, and equal means shade in our dot. It said greater than -8, so that's an open dot. And anything in between would be okay. It's a number that you're thinking, anywhere in between -8 and 4, but not equal to -8, but it could be equal to 4. So writing that as an inequality, I'm going to say x could be greater than -8, but it could be equal to 4 or less than 4. Okay, let's read the second one. I'm thinking of a number that is at most 0 or at least 2. Okay, so the word or gives it away for me, so I think this is an or statement. They're thinking of a number that is at the most 0 or at the least 2. So I need my 0 on the graph and I need the number 2 on the graph. And at most 0 means If we look back up, at most means less than or equal to. And the other key word was at least. So greater than or equal to. So they both have equal to. So it could be 0 or less, but it also could be 2 or more. And remember, ors go opposite ways. And we also write the statement in two parts. First of all, x could be less than or equal to 0, or it could be greater than or equal to 2. And you have to write the word or when you write the inequality for an or. For an and, you don't see the word and. They're just all connected together because ands stick together. All right, guys, this concludes our video. Try to do the next 4 on your own and talk to me in class when you return and see how you did.